My name is Angie Jim Osman, and I'm an architectural and urban designer. I'm also a director at Allies and Morrison, and have been there for 17 years, and previous to that, practiced in Canada as well. So conservation and decarbonisation, not versus. The first photo is interesting. It's of our offices in Southwark, and it highlights the fluidity of our work. It's comprised of 3 buildings, one purpose-built architectural office completed in 2004, and the neighboring building, a Victorian warehouse adapted for office use. The first is on the grounds of an empty bombed site after the Second World War, and the second a Victorian warehouse with its exposed Victorian brickwork. The third to its rear is a cross-laminated timber building built in 2015. It goes to show that the binary approach of conservation versus decarbonisation would not be a straightforward debate. When Architecture Today invited me here to speak, I asked myself how I can contribute to this discussion. After all, I'm a practitioner, learning daily from the experts around me, and do not purport sustainability as my expertise. From a young age, I had a sense of material use and waste, and I was cultured to be a thrifty person growing up with my grandmother and her practice of saving tin cans for storage and reuse of pots for growing. I was taught how much energy and resources goes into making something, and that reuse was paramount. That same consciousness carries through to my work 40 years later. The question of whether something is necessary and if something is of value, should it be retained, and how its use can be extended. Our practice has worked across many sectors, from retained to new, garnering over 42 RIBA awards. My work over the last few years has primarily been in urban design, residentials, and workspace. From Imperial College, Greenwich, Brent Cross, and King's Cross, I've seen through my work that design is not just a carbon issue, but social and financial considerations too. The King's Cross Master Plan touches on many of these themes. Though it once was a thriving hub for goods and transport, by the 1980s, it was a disconnected and derelict piece of city, making getting through and to it difficult and unpleasant despite being in the center of London. Working with Argent and Dimitri Porphyrios, the master plan sought to bring back a more sustainable and intensive plan, with walkable places and infrastructure that can extend its lifetime. Just like the Victorian infrastructure, the green spaces and network of streets and the upgraded services below, it aspires not just to be of the 60-year typical lifespan, but to 200 years of investment. The plan also sought to retain existing buildings that are of value to continuing its living history. I worked on the early stages of the German Gymnasium, built in 1866. It is a key piece of British history. I learned of its cultural value as a site of the Olympian athletes showcasing sport within London. Through careful documentation, repair, and adaptation, we renewed its use. It is now a restaurant showcasing German cuisine for all to enjoy. And it also activates a key public square outside King's Cross Station. 200 years after the inception of the master plan, I now lead a project team designing the last building of King's Cross. It is a new residential building that will provide 176 homes for residents on the site. The building is designed to use 100% renewable energy through green gas and electricity, becoming a carbon neutral estate. The scheme is designed to BREEAM Excellent with Code for Sustainable Homes Level 4 requirements for responsible sourcing, site waste management, and efficient material use through prefabrication. It also uses well guidance for ensuring a good access to green space, daylight, sunlight, and ventilation. These performance measures are sometimes harder to achieve with retained buildings, and given in this context where the site previously held derelict sheds, the new building provides a new life and homes to the site for many decades to come. Around 300 councils have declared a climate emergency to reduce their own carbon emissions and to take part in climate change. Retention and reuse may be a solution advocated, but its true impact and cost is not always understood. Retrofit is decades old. Allies and Morrison have been engaged in retrofit for 30 years, and it comes in varying degrees. The different shearing layers of construction have different lifespans. It is not just a question of old or new, but degrees upon which one should approach a site, and it involves analysis of its social, environmental, and material legacy. Reuse can span from retention of facade, its superstructure, upgrade of its systems, or its cultural assets. Like our crane building, which had a facade replacement, or our work at Royal Festival Hall, which was much more involved. This is not an easy task, so our work is informed by the LETI Guide, by the London Energy Transformation Initiative, which our head of sustainability at Allies & Morrison and James Woodall leads in our contribution to support. Its transition from London built environment to net carbon zero. The key is whether the carbon payback is achievable in 10 years to limit global temperatures from exceeding 1.5 degrees above pre-industrial level. One is always aware of the impact of new construction and the emissions for demolition. When approaching a new project, we review the context and the existing buildings if it's there. There is always a dilemma of whether the extent of design life of either the retained components or the proposed new build will last. And will it be best practice for embodied carbon, but also its operational carbon is in line to climate change targets? We have a duty to ensure buildings do not become prematurely obsolete, protecting these assets and assessing whether they're resilient to future change. It's really important. Allies & Morrison have invested in this duty with the creation of our upfront carbon tool. This not only allows us to calculate the environmental impacts associated with new development, but also an ability to view this impact against a retrofit option where existing buildings exist. We have a role to play to assist our clients in setting briefs and strategies, to prompt our design teams and outlines planners and stakeholders and policymakers what to expect. If after analysis, new, to whatever degree, is a solution, then we, designers, consultants, clients, and councils, should be held to the highest standards to maximize its efficiency, its social value, and its responsible use, to ensure it is a positive investment that lasts for future generations and the planet. Thanks.
My name is Darren Price. I'm an architect at Adam Architecture. We are known as traditional and classical architects and have worked on many historically important buildings around the country. The UK has the oldest building stock in Europe. We've got approximately 26 million existing buildings. 1.2 of those are in conservation areas and approximately 440,000 are listed. We know that the vast majority needs significant upgrades to achieve net zero. We can't simply replace, and 70 to 80% of those which are with us now will still be with us in 2050. We need to look at these buildings now and how we can make them as energy efficient as possible. The advantage is that each of these buildings holds embodied carbon. This can make up to 75% of a building's total carbon footprint before it is even occupied. We can think of this as a carbon credit, yet this is vastly underestimated. We'd be wise to take this into account when reaching any conclusions around our future carbon footprints and our target measures. We also often think of the owners of listed buildings as guardians, but we all have a shared responsibility to make sure our homes and buildings are as energy efficient as possible. I don't see conservation and decarbonisation as two opposing positions. It's quite the contrary. I believe there is a key dynamic to play to conserve the past, capitalise on the spent carbon, and adopt new construction interventions alongside traditional crafts to ensure that they are performing as efficiently as possible. But whether listed or not, simply retaining as much historic fabric as feasible will avoid the creation of new embodied carbon. We can refer to this as avoided carbon. This is a Grade 2-star manor house in the Cotswolds, and I show this as an example of how we can upgrade a historic building for the future, and how adaptability for renewables and a changing energy supply can be achieved. This is a private home dating back to the 15th century, and it'd been on the market for some time. It looked as though it might not even get sold, and it could potentially fall into disrepair. An overseas client saw an opportunity to purchase and convert from a private home into a private institution. For those less familiar with the uses, the institutional use meant that they could still use the property as a private home, but they had the benefit that it could also be used as a quiet retreat for guests of the clients and also their foundation, which promotes the arts and sciences. We took a fabric-first approach, which included major repairs, removal of asbestos, and modifications to the layout to undo generations of incremental change, which are quite frankly resulting in a pretty confusing experience. We undertook a staggering amount of historical research, dating the property, understanding its incremental phasing, and more historically significant interventions. The most recent works have been carried out in 1925. It was our mission to understand and fully evaluate the building before developing early design. The building became the client. From a practical perspective, historic projects also provide a testing ground for interventions, contributing to thought leadership, research and development. It's a balance of protecting the historical significance, but also securing its future to ensure it can survive. By way of example, here we were able to look at the entire fabric. We looked at the roof, the walls, the floors. We identified what was working, what wasn't working. If we take the floors as an example, there was an opportunity to replace a poorly performing ground floor slab that was actually causing damp throughout. So we got permission to remove the slab, but actually replace it with a more sensitive, breathable structure. And at the same time, take the opportunity to put underfloor heating in, and then finish it with the previously laid original flagstones. We can't always address everything. Air tightness, for example, in these types of buildings, we would never try and achieve. We look at the windows, we look at the open fireplaces. Those elements are contributing to the significance. So here we take the decision to let it be as original and authentic as possible. Where we can do our work, we can look at the materials that we are specifying. We look at biosourced materials to achieve a more circular economy. We have sheep's wool, wood fibre, lime render, and locally sourced materials of stone and timber. In this particular case, we also looked at the existing services, which were well beyond their operational lifespan. We carefully deconstruct the walls and the floors to open up the voids and provide new routes to redistribute water pipes and electrical feeds, and obviously all of the modern interventions of Wi-Fi and Cat6 cables, etc. More importantly, we can also adopt renewable energy strategies. We can remove the internal plants such as boilers and pumps, water tanks, appliances. We can locate those in an external position. We can simply feed from below ground into the building. We generate a new energy centre. The beauty of this is that any future adaptations can be carried out remotely within the energy centre itself without any repeat impact to sensitive finishes. It's essentially a large, complex puzzle with every piece carefully deconstructed and reconstructed. But it teaches us we can, and in this particular case, upgrade the performance of a building fabric while retaining its heritage value. Going back to the change of use, it was also necessary to incorporate fire strategy, acoustics. Quite often you get the paraphernalia of LED lights and escape signs. Here, we need to look at compensatory measures. We need to retain the feeling of and the appearance of the building. Ultimately, we were successful. The building has a new lease of life for its function, and it meets one of the client's fundamental requirements, to retain the appearance of a private domestic property. We tested this idea and compared the completion photos to the earlier 1925 photos. We can see that the authenticity of the building is retained. We can look at the roof structure, look at the finishes. We now know that there are underfloor heating pipes. Ultimately, the building looks as though it was, but is now operational as a very contemporary structure. I find conservation is about making lots of complex, isolated decisions, creating something greater than the sum of its parts. We have various conservation philosophies to support these decisions. And it's interesting that the climate challenge provides us with an opportunity to test the previous ideologies. Ultimately, adapting a listed building to become more energy efficient is the moral thing to do, but it needs to be carried out in a way to respect the story and the historical significance of the building. Connecting renewables or adding insulation to a leaky building can be seen as a contemporary, necessary measure, adding life to the built fabric, carried out in an honest way at the time in which the building exists. It's a rehabilitation, if you will. Personally, in the case of this example here, it is critical to retain the soul and the atmosphere of the building, acknowledging the history and the story, and working with the legacy of the previous owners and architects. It is often the very reason why it was listed in the first place. So to conclude, my position is that conservation can be hugely beneficial to working towards net zero, and the lessons learned from upgrading the large historically important buildings can be applied to the 80% of the existing buildings which are likely to be with us in 2050. I'd like us to see us talking about avoided carbon, discussed alongside embodied carbon and operational carbon, and quantified with the same amount of importance. Nobody wants to be in a bad building, and it's a question of huge balance. But we need to understand the carbon cost of replacing poorly performing buildings with incredibly energy efficient buildings. If this takes us beyond the tipping point and we look at the timeline of the carbon payback, it's a little bit concerning if we're in a position where we're already in a climate catastrophe. This is why it's been said, and I'll say it again here, we can often think of the existing buildings as being the greenest buildings.
So welcome today. My name is Geeta and I'll be speaking on behalf of Atelier 10 on adapt and reuse conservation versus decarbonisation. So Atelier 10 was founded in London in 1990. Our focus is on high performance building design. We work across several sectors and we are world-class environmental solutions. Each year we offset 100% of our CO2 emissions as a company. We are also a Gold Leaf member of the UK GBC as well. So in terms of sustainability is not new. So there was a book written by Barbara Ward and the Club of Rome report, which was an unofficial report by the Secretary General of the UN Conference on the Human Environment. At the time, the idea of combining the environment and development agendas was new and needed to be fought. So in 1972, if the present grows a trend in the world, population, industrialization, pollution, food production, and resource would be depleted, continuing to unchange the limits to growth on the planet, which will be reached sometime within the next 100 years. In 1970 and 1980s, there was the oil crisis, so there was a driver for fuel cost and a driver for conservation of fuel as well. So in terms of the hole in the ozone layer, there's an imminent catastrophe as a driver for change in 1987. Greenhouse gas emissions were starting to have a similar impact on the hole in the ozone layer. A new awareness of impact of humans on the atmosphere was detailed at that time, and the consideration of global warming, GWP, as a key issue was also highlighted. Refrigerants and insulating materials were particularly affected. So change is visible. You can see it today in many parts of the world. So in terms of conservation and decarbonisation, there is no straightforward way of thinking about it. Conservation protocols differ according to the age of a building, the methods and materials used in construction, and specific locational factors. So they currently, in terms of carbon emissions, there's a tunnel vision on how to actually equate and actually look at how you provide a rateable target. There are many greenhouse gases as well. So there are HFCs, CFCs, N2O, CH4s, and looking at the whole carbon cycle will help reduce overall carbon factors. So as a company, we look at embodied carbon. Why do we look at embodied carbon? Embodied carbon is the amount of carbon that's emitted during the construction of a building, the extraction of raw materials, the manufacturing and the refinement of materials, transportation, installation, and disposal of all supplies can all produce embodied carbon emissions. In 2019, the UK government signed a legally binding target to achieve net zero carbon emissions by 2050. 80% of the buildings of 2050 have already been built, so decarbonising these buildings will play a vital role in the UK's journey to net zero carbon. There's no one-size-that-fits-all approach, but with the range of technologies available today, solutions are there to be found. The UK GBC has led the way in the UK property sector in defining what we mean by net zero carbon. Its document, Net Zero Carbon Buildings, a Framework Definition, was published in 2019. This defines the principles that achieves net zero is about reducing demand both for energy and materials, with offsetting the last resort for residual emissions. The UK GBC defined a target trajectory as seen on the screen for operational energy efficiency for commercial offices, which can be applied across the property sector. That to be net zero carbon by 2050, we need to reduce our buildings' operational energy use intensity by more than 60%. While the details of the calculation may change over time, the scale of the challenge is very clear. So in terms of embodied carbon, which is the upfront carbon that you have to look at, there is also an awareness of operational environmental impacts, which is increasing rapidly among some commercial occupants, particularly larger organizations with internal sustainability commitments. Achieving operational net zero carbon requires a partnership between owners, occupants, and operators. Operational carbon is not just about design, it requires a combination of the right design, facility management, and occupant behaviors. So the graph in front of you shows by 2030 the greater than 80% embodied carbon, and how operational carbon and embodied carbon would be targeted over time. So in terms of actually meeting life's carbon targets, getting the balances right and avoiding unintended consequences is best done with a holistic approach that uses an understanding of a building and its contents, its significance, and all factors affecting energy use from the starting point to the end, and looking at the future as well. Building uses resources such as energy, raw materials, water, etc., which generate waste and is potentially harmful to the atmosphere. Embodied carbon emissions arising from new building constructions or refurbishments can represent a significant portion of a building's whole life carbon impact. The goal is to reduce all carbon emissions to net zero through the life cycle of the project. So some hotspots that you could actually target as part of embodied carbon is looking at design and optimization, looking at reducing, reusing, and recycling materials, thus decreasing embodied carbon throughout the life cycle of a project. So in terms of height, embodied carbon, if you look at height of commercial buildings or reuse of existing commercial buildings, goes up dramatically with the building height as well. Building height influences energy consumption directly through mechanisms such as changes in external temperature, wind speed with altitude, access to daylight, solar gains, as well as the need for lifts. So in terms of upfront carbon, how an assessment could be detailed is looked at the MEP, the furniture, fixtures and equipment, finishes, facades, superstructure, temporary works, external works, and substructure. The LETI best practice, Band C, targets 600 kilograms of CO2 emissions per meter squared on the GIA. So another hotspot to target is structural embodied carbon. So moving the dial on looking at columns, specifying low carbon steel, building lightly, reusing, building cleverly, innovating the building, and building efficiently. The grid size also matters. So a 6x6 grid, for example, will have a lower embodied carbon on an A1 to A3 type setting versus RC frame PT slab. So that's one area that could also be targeted in more detail. Again, looking at some of the buildings we've been working on recently, there's been a 20% saving in embodied carbon, looking just on the structural grid itself. Another key area is facades are also a hotspot within buildings. You could focus on aluminium framing, cladding materials, internal material skins, replacement cycles, and external shading. There is a significant aspect on projects of the facade being complicated, so detailing of the facades would generally reduce carbon where possible. And materiality, think about the amount, and remember the service life, think about transport, and as I said previously, detail is very, very crucial. Another area to target is the MEP. For example, everything matters, including cables and containment, on-floor pipes and ducts, risers, bracketry, everything adds up for in terms of the carbon hotspots. What does good look like in terms of refurbishment and reuse? So in terms of 1 Triton Square, retained structure in Powell's, 100 Liverpool Street, they've retained 50% of the structure. 22 Bishopgate, 100% of the retained foundation is still being reused. So in terms of emerging practices and technology, there's been a recent project by Atelier 1, which is called, and this the AA at Hook Park, the Big Shed. It's a 500 square meter assembly workshop building erected in Hook Park, Dorset. The project demonstrates the potential for using low-value local timber in and around its area. The AA Wood Lab will advance the role of woodland campus in Hook Park and also reduces the use of embodied carbon and operational carbon. In theory, or in conclusion, more design less accounts for less, and in terms of reuse and decarbonisation that assists in construction and could help progressing to net zero carbon by 2050. So what might be the future? The greenest building is the one that already exists, rather than actually rebuilding new buildings. Thank you very much.
So my name is Julia, and I'm here to talk about adapt and reuse, conservation versus decarbonisation. I am currently sustainability lead at PLP Architecture. So PLP are an international architecture firm, and we do a whole range of projects both in London and around the world, in lots of different climates and cities and regions, and different planning policies as well. So today I'm just going to run through 3 kind of case studies on this subject, and some quite different projects, looking at how we evaluated the site and the brief in order to come to a conclusion whether or not to reuse or adapt the particular project. So at PLP, we evaluate all our projects individually, taking into account site context and brief when we're undergoing these kind of considerations. So the 3 projects that I will run through are Corsica Place, which is in Milan, Italy, an office building, Cleveland Clinic, which is based in London, which is a healthcare centre, and Holborn Viaduct, also based in the City of London, an office development, which has just gone through planning. So the first case study is Corsica Place. So as I said, this is based in Milan. So the original building seen on the left was in a very prominent location, but very underutilised at the time. It did undergo a refurbishment already in the past few years, the past few decades, sorry. And when we approached the site, there wasn't necessarily an option for demolishing the whole building. The idea was that we had to keep the superstructure and the substructure. It just so happened that this happened to be the largest embodied carbon proportion saved. And what we wanted to do is significantly improve the performance of this facade by recladding it, both the kind of thermal performance, but also the daylighting within the building as well. But also keeping it as the same use as function as it was before, as an office use. So it just so happened that the kind of bare bones of the building was fairly good in terms of the structure, the floor to ceiling heights, etc. So it made it a fairly good candidate for recladding the building. The next project is slightly different in terms of the use. So this existing building in London is a 1950s neoclassical facade. It's based in a conservation area, so there was kind of limitations in terms of what we could do in terms of the facade. The idea is that we had to retain the facade because of conservation. There again was a refurbishment done in the 90s from the existing building. This turned it into an office use, and because of this refurbishment, there actually was a misalignment between the structural slabs and also the facade. So in order to turn this into a clinical use, we ended up retaining the vast majority of the facade, about 60 to 70% of it, redoing the interior, the structure, in order to kind of level it on the ground floor and also to provide better spaces within. And with the existing facade, massively improving the thermal performance of that as well. Obviously, there were some limitations in terms of how much additional insulation we could use onto the existing facade, just because of the huge facade build-up. So this was kind of a challenge, trying to balance the building performance, but also the new use, making sure that it was still usable for the main functions of the clinical centre as well. And the last project is Holborn Viaduct. So this is in the City of London. There on site were 3 existing buildings, all offices. And the brief for this was to, we had a pre-let tenant, and the brief was to have a consolidated building for this tenant. So this was probably one of the first buildings that went through the whole life carbon assessment through the planning policies. And from this process, we learnt a lot in terms of how to make sure that we are properly evaluating a series of refurbishment options, rather than do the kind of business as usual approach where you will settle onto the new build. So this project and the scheme evolved through a lot of iterative studies, lots of stakeholder consultants, and also pre-application meetings with both the design team and the planners. And what we realised was the kind of massive advantage of collaboration in this project to make sure that we were considering everything as a whole, not just the kind of carbon story, which was extremely important, but also the kind of qualitative aspects in terms of delivering a new office space in London. So the actual carbon calculations came out that it was very similar for the refurbishment and the new build. However, there were benefits to the new build that we could bring in terms of the thermal performance of the facade, the way in which we could use the building in terms of mixed mode ventilation, and also how we treat the design for disassembly as well, and make sure that at the end of life, when we're designing the facade, for example, it's designed to be disassembled, and also incorporating other circular economy principles, such as making sure that we retain some of the stone on the facade as well, in order to create the new facade on the proposed development. So from these kind of case study projects and experiences that we've had, and obviously with the changing climate in the industry, both in the UK and abroad, what we've done at PLP is make sure that every site and every brief that we have, we analyse it as early as possible. So one of the key aspects of the job that I have is almost like an in-house consultancy to make sure that we do early stage analysis for whole life carbon, looking at the kind of quantitative aspects in terms of carbon calculations, when we're evaluating either refurbishment or new build, but also making sure that when we are studying different options, we are using an iterative approach and using ways that we could substantiate claims of different variations of our building design. So whether that be deal with buildings that are designed for occupant use, and we want to make sure health and well-being and the usability of the space and the function of these buildings are as good as they can be. And we try to do that using our kind of in-house tools and performance analysis.